Okay, is this working? Okay, sorry for the mess. It has an explanation. So does anyone know what a HackASac is? Okay, so the history of the HackASac is I was going to go to UFT Hacks and build some stuff in Python and totally win. Get into that more later. But I like hardware as well as programming stuff and software. So I made a portable HackASac for hacking. So, still work? Okay, cool. First of all, I want to make a shout out to HackLab, for which this wouldn't be possible because I learned so much stuff from those people. My laptop says hack on it 4 times. You guys can check with me later about that. Okay, so now let's get a tour of it. So hardware hacking, you need tons of different stuff. And also, when you go to a hackathon, you don't even know what you're going to build. So you need to become prepared with everything. A robot platform. So this is just a simple robot platform that can be controlled with, has 2 DC motors. And this relates to Python because it has an Arduino on it. And you can actually write Python code that compiles to Arduino. And as well, you can also use the PySerial library to control it with your own C code that you program. I have some source code on my GitHub that you can use to control this with PySerial. I also have a Kinect sensor. OpenKinect is a really, really cool library with an awesome Python wrapper. It actually just exports the entire depth array as an NumPy array that you can do anything you want with. That's pretty neat. Okay, I got some batteries, got some alligator clips. I got stepper motors, DC motors, and servos. Wi-Fi pineapple, because that's fun. As well, a bunch of Arduinos. And for the cool stuff, we got an ESP8266, which will actually turn an Arduino into a fully fledged web server that with Wi-Fi. So you can play around with Flask and Django in order to control any project you have that you could possibly imagine. Also, Bluetooth. There's Bluetooth libraries for Python. Now let's get this thing open. What kind of hardware do I have in here? So also keep in mind, there's a GPIO library for the Raspberry Pi, which is hiding back over there. And that allows you to actually interact with all this stuff directly. Because it has PWM output, digital inputs and outputs. Add in your own circuitry, and you can literally take over the world. What else? What any cool stuff I have here? I have an XB controller for wireless communication. An Arduino pilot, so you can program some stuff using Arduino, and you can use the Python to write code for the Arduino, which then can now control a drone, which is pretty neat stuff. Anyways, enough about this thing. Let's keep talking. Okay, so does this thing sound pretty cool? I think it's pretty cool. So I want other people to have HackASacs as well. So that when you go to a hackathon, you're not the only person doing hardware. Why would you want to have a HackASac? Projects. We just went through all those projects, and I really like those projects. Also, there's enough stuff in there to come up with a project from scratch and build it without moving. There's also a soldering iron in there. It's important for prototyping, because you ever want to build a project and then realize you don't have the correct hardware? I know you guys are all just software guys, but it's OK. So with this, depending on what kind of configuration you use in your own HackASac, you can literally invent something in your head, draw it on the paper, which is also in there, and then you can literally build it right there and then. Hackathons. Got my UFT hack sticker on the back over here. Oh, great. Anyways. Okay. Where's the cursor? And there we go. Okay, so this is everything I brought with UFT Hacks to me last year. And you can see I actually fit all of this in your average gym bag before I had one of those. So this was actually HackASac version 1. So in here I had a lot of the same stuff, but here's some 3D printed parts. I was working on a 3D printed robotic hand, but it requires 300 hours of printing, so I ended up giving up on that. This is a 6-channel PWM controller, so you can use that to control a drone or obviously a car, or you can do more complex stuff with it. I have 6 fully fledged servos in there for the robotic arm I was working on. Also, like USB battery packs, those are handy. I ended up placing 3rd place last year at EFG Hacks, and that was the first hackathon I ever went to, so I have a 100% success rate. That's pretty great. That's what I won with. It was a bit of a joke. Talk about that another time. So when I decided to go build, so after the duffel bag, which was literally this big, and I fit all that stuff in it, that stuff fit in a duffel bag this big, I had to upgrade it. So I went to Amazon and bought one of these for $40, and it showed up the next day. It's pretty great. So if you guys want to build your own HackASac, you can start getting one of these hockey bags. You can put like 50 pounds of stuff in it. The robots can be controlled using Python, as I said earlier. You can like implement a Flask server in order to have anybody on the internet control your robot. That's fun. Oh, cool. This is the code I used. So this uses a text file instead of a Flask server. So basically, it just reads the text file in using a while loop, and depending on the character inside the text file, it sends a byte to the Arduino, and it goes forwards, backwards, left, right, or stop. Yeah, it's pretty great. This is the Arduino code. So basically, I'm using Adafruit. I love Adafruit. You buy some of their stuff. It's amazing. So I'm actually using their motor controller, and you just literally just do like left motor run, like releases for stop, left motor run, like forward, all in caps. And it's really easy to control using their hardware compared to configuring an H-bridge yourself, which has a large learning curve. So basically, I was able to implement their controller inside my system and communicate with my laptop and/or Raspberry Pi to tell it to move around. Also, you can like host the entire server on the Raspberry Pi itself. And in the near future, I'm going to be implementing. It's going to have a camera on it, and hopefully, I'll be able to send it to class for me. Okay, so I talked about that Kinect sensor earlier, and I talked about how you can just get the entire depth array as a NumPy. The depth array is just as a NumPy array. It had literally each depth part is literally 1 byte, and you can play with that however you want. If you want to get one yourself, they're $20 on Kijiji, but you need the USB adapter because Microsoft likes proprietary ports. And even when you buy the adapter, it's still the cheapest one on the market. That's like Amazon for $15, or like $40 in total. Here's some specs for it. It gives you a depth array of 320 by 240. So if you want to be playing around with that, that's capable of tracking all the joints on a human being. The second version is 512 by 424. So if you want to upgrade and want to spend $200 on the system, you can still play with it. Also, keep in mind, you can skip Microsoft's proprietary software and go straight with OpenConnect. It also supports the second version, right? And then you can actually help them out with the project as well. Anyways, that's using Kinect. You can use that to build robots, do whatever you want. The demo gods did not like me today. That did not work. So I've had this working, but I decided to install Ubuntu from scratch last week, so it's not working right now. So this is what the depth data from the Kinect sensor gives you. This is using the Python wrapper with Open Computer Vision. So this is the depth array being rendered as a grayscale map, and this is the RGB map that the same sensor right over there gives you. And that's another robot I have. So as testing it out to see what its limits were, it cannot detect. So the way it works is it puts an infrared beam array on all the objects, and it looks at the 2 different points of it between them, and from that it's able to generate an array. Therefore, if 2 points do not render beside each other, it doesn't understand an object. So if you don't have a flat object, say like this size, about 1 inch, 2 inches, it doesn't render it. For example, like that piece of wire. Also, I did all this prototyping in the Digital Media Experience Zone here at Ryerson, which is on the 3rd floor of the Student Learning Center. Yeah, so here's a great example of the different types of depth. You can see this man's face is a lot closer, and I'm a bit farther, and it's able to differentiate between them. That's the code. literally that will give you what I just showed you.
And I'm very, very sorry because your HackASac is awesome, but we are going to have to stop. But are you open to questions after the session?
Sure.
He's open to questions after the session. Please thank Paul.